Hello everyone, this is Mr. B with some Algebra 2 homework, 3.5 systems of 3 equations. Usually when you attack system of 3 equations like this, I pretty much always go straight for the inverse, unless you have something that's gonna kind of round itself out really nicely and be very simple. Like if you had x equals 2y plus 1, I might use substitution method there, just because it won't get too complicated. But if we were to try to say solve for z in this case with this top equation and then sub that in, we would get, let's see, z equals negative 4, would actually be z equals 4x plus 2y plus 10, and subbing that in and then distributing it just gets really, really gross. So I pretty much always go for the inverse method. You can attack any variable if you want to. You can always solve for like z first, or you can always solve for y first. It's totally up to you. I usually look at each question independently and think what's going to be the easiest one to solve for first, and then I just kind of take it from there and solve as I go. So the first thing that I'll do here, I'll just look at my numbers. 4 and 3, to get these to all have at least the same absolute value, I would have to multiply the 4 by 3 and the 3 by 4. That's going to make some pretty big numbers, so I don't really want to do that unless all my other options aren't very great. For this one, I would have to get the 2z up to 6z, this 3z up to 6z, and then I would have to multiply this whole top equation by 6. I don't really want to do that either, but you absolutely can. What I'm going to do, though, is just focus on these y's. The highest value that we have here is that 4y, so I'm going to have to multiply up to get to 4. But really, I just need to multiply the top and the bottom equation both by 2. That should round everything out and make the coefficients equal the inverse of at least this bottom one, because we'll get up to negative 4y here, and the top two equations will have positive 4y. So we'll be able to eliminate y from the system of equations without losing really any information. So let's do that. We'll multiply this top one and this bottom one, the entire equation, by 2. So this top equation we'll get is 8x plus 4y minus 2z equals negative 20. And I'm going to write this other one here, the one that we're going to add to the other inverse, just down. You'll kind of see why here in just a second. I just like to keep all my work organized and pretty much do this the same way almost every single time. Equals 2. And now I'll multiply this bottom one, this inverse equation, by positive 2. So I get 6x minus 4y, so those should eliminate, plus 6z equals 80. And I'm going to write down the same one over here because we're going to add this equation, this bottom one, the one with the inverse, to both equations. So I'm just going to write down the same one, 6x minus 4y plus 6z equals 80. And then I'll add down. 8x plus 6x gives me 14x. And then the y's disappear. Negative 2z plus 6z gives me positive 4z. And that equals 60. We'll do the same thing over here. We get 9x, the y's disappear, plus 8x equals 82. Now we need to get one variable eliminated here again. Oh, not x on that last one. What am I doing? That's going to be a z. All right. I could get rid of the x's, but I would have to multiply these up pretty big in order to do that. I don't really want to. I can multiply this left-hand equation, though, by negative 2, and the coefficients in front of z, 8 in this case, on the right equation, I'm sorry, those would kind of round out and equal the inverse of the other. So I'll do that, multiply this one by negative 2. So I'll get negative 28x minus 8z equals negative 120. And then I'll add this other equation to it, 9x plus 8z, and that equaled 82. I pretty much always have my calculator right next to me for these because I just don't want to take negative 120 and add it to 82 in my head and mess up. So I'm just going to let a calculator do it. Same thing with the negative 28x and the positive 8x, or the positive 9x, I'm sorry. So let's see. If we take 9 and subtract 28 from it, we get a negative 19x. And that equals, let's see, 82 minus 120 gives us negative 38. And if we divide everything by negative 19, we get x equals 2. And now we can just plug that number into any of our equations and get to the z, and then we can plug those two numbers into um, any of those first three equations and get to the final one. So let's see, we'll plug it into, why not this one here? So we get 9 times 2 plus 8z equals 82. So we get 18 plus 8z equals 82. We'll subtract 18 from both sides. And I use my calculator for this one too. Why not? It's right here. Minus 18, 64. 8z equals 64. And let's divide by 8. That's going to give us 8, of course. So z equals 8. You can see up here in the top, I did give you guys the solutions. So if you're getting to the wrong answer with any of these, check through your work, see if you can find where that mix-up occurred. If you can't, I would say give it a pause and then talk to us in class. No worries there. But now we can take these two numbers and plug them in. I'm going to use, it does not matter. It really doesn't. I'll use this, let's see, middle equation because it equals 2 at the end of the day. That seems like it's going to work out nicely. So 3 times 2 plus 4y plus 2z plus 8, or 2 times 8 equals 2. So we get 16 and 6 plus 4y, that equals 2. Really that's 4y plus 24, 22. 22 equals 2. If we subtract 22 from each side, we'll get 4y equals negative 20. And after we divide by 4, we will get y equals 5. Oh, negative 5. And that matches with our ordered triple up there. If we write these in, 2 for the x, negative 5 for the y, and 8 for the z, we can see that matches with the provided answer. Let's do one more. One more now, then we'll move on to the second page. Number 3 will be pretty much a breeze, though, if you know how to look at that type of question. So we'll cross that bridge when we get there, though. Let's see. I'm going to rewrite these spaced out. Again, this is just trying to keep my work organized. So 2a plus 3c equals 11. I'm leaving a little space here for the b's. Let's see. We get 4b minus 5c equals negative 7. Then we get 10a minus 5b equals, let's bring that 0 over. There we go. All right. Now we need to figure out one to eliminate. One thing I actually see right off the bat is this one. We can simplify. So I'm actually going to do that now. I'm going to cross out this one and just divide that entire equation by 5. It's something that we can totally do. So we get 2a minus b equals 0. Now this one kind of opens up. It should be pretty easy for us to jump to this one. I'm going to multiply this bottom equation by negative 1. And that is going to give us negative 2a plus b equals still 0. And I'm going to add, let's see, this third and this first equation. So I'll add 2a plus 3c to negative 2a plus b. This top one equals 11, this bottom one equals still 0. So really, once we add these down, we'll get b plus 3c equals 11. Now we have two equations. I'll rewrite this next one here, 4b minus 5c. That equals negative 7. I'm pulling this equation from right here. right. I mean, we can get rid of the c's. We would have to multiply that bottom one by 3 and the top one by 5. Let's actually do that, because again, I hate working with negatives. If I can avoid it, I absolutely will. So we'll multiply this bottom one by 3 and this top one by 5. We'll get positive 15c in the top and negative 15c in the bottom. So let's rewrite those. We'll get 5b plus 15c equals 55. Remember to multiply this constant out in the front, otherwise we will get to the wrong answer. This bottom one here, we will get 12b plus minus 15c equals, let's see, negative 7 times 3 is negative 21. And then we'll add those down. We'll get 17b, the c's will cancel out, and that equals, again, I'm going to use my calculator. I believe it's going to be 34, but why leave that up to my tired brain? Yep, 34. And then we'll divide both sides by 17, and that gives us b equals 2. Now we can plug that into anything. I'm going to use this equation right here, because it should just work out nice and simple and easy. We'll plug in 2 plus 3c equals 11. We get 3c equals 9, and then we get c equals 3. All of this is working out for us so far. We can plug in, let's see, plug the b into this equation right here. Now we can use either the 10a minus 5b or the 2a minus b. We'll get the same answer, no worries. So we'll do 2a minus 2 equals 0. So 2a equals 2. That means a equals 1. And that checks out with our ordered triple right up here. So if we wanted to write that out, let me move that down a little bit so we don't get confused. We would get 1, 2, 3. All right, moving right along. Hopefully this one did not stump too many of you guys. Really hope it stumped none of you guys. What we want to prove here is that there is no solution to this system of 3 equations. We can't simplify anything. That's something that I really should have done first before writing out everything for this one, but I'm trying to make that a habit for myself as well. So can it be simplified? No. Next step then would be to try and get rid of some variable. Let's see. This one's not going to work out too pretty because none of them are like kind of geometrically or arithmetically close to each other. We already have a negative for x, but we also have positive y's, and I mean negatives and positives everywhere. This one's kind of hard to find a good place to start. I'm going to start with x just because there's not really any other area I can start. If I multiplied all these numbers together, or if I multiplied all these numbers, if I needed to get them to an integer value, the closest one that I could get to would be 12. 4 times 3, 3 times 4, and then 2 times 6. I don't need to use any negatives if I use this x, so that's what I'll do. So I'll multiply this bottom one by 3. I'll multiply this one here by 4, and this whole one here by 6. So this can be a lot of little arithmetic. That's why I always suggest having your calculator near you. I'm going to use it for the 4s and 7 and the 3 and 8. Why not? Might as well. So this top one, though, we'll get 12x minus 18y plus 24z. Oh, and I'm definitely using it for 6 times 14. 6 times 14, 84. This next one here is, I'm going to write it again. I'm going to write it over on this kind of side because this is what I'm going to add to the inverse equation. So we'll get, let's see, 12x there as well, just like we wanted, minus 16y minus 4 times 7 is 28. 28z equals 14 times 4 is 56. Now we'll do this bottom one here. We get negative 12x, just like we wanted. We'll get 18y, okay, and then we'll also get 24z. might kind of see where this is going at this point. This might have kind of unlocked it for you, but we're still going to write everything out. This one is just repeated, plus 18y minus 24z equals negative 15. So we'll add this first one down. We get 0 plus 0 plus 0 equals, let's see, 84 minus 15 is 69. That does not shake out. This would give us 0 equals 69. Just like we saw with systems of two equations, these three variable equations, if you want to think of it in terms of space, something that's kind of easier to understand, think of them as planes. Instead of just a single line, they're planes. When we have three planes, the first two planes will intersect in a line and form a new line that's traveling through three-dimensional space. And then that third plane will intersect that line at just one point. However, what we've proved right here is that the first and the third equation are actually parallel planes, so they never intersect. That if they never intersect and never form a line, even if the third equation, this middle one, the 3x minus 4y minus 7z equals 14, it'll intersect both of those planes and form two lines with those planes, but we're never going to get a solution. If you get to this point, you can skip all of the work of adding these together. We already know that there's no solution. So if you highlight this and write no solution, that is perfect. That's exactly what I'm looking for. Right, let's jump down to the next one here. Oh, that's not wanting to turn off. There we go. All right. Let's see. The numbers in this one get very large. Make sure to stay organized. They certainly do. This one is going to be just a huge equation. But after we solve the first one, I would simplify. And you'll see how that can help us out as we go through. What I would jump straight towards is the p's here. Because we have a 41q and a 47r, we know that those are going to just get even larger. They're just going to get super huge. So I'm going to skip on those and just try and tackle the p-values first. Now, finding a coefficient that is going to equal these can be kind of tough, but if you realize something, if we take just the numbers 13, 17, and 19, those are the ones that we're working with. These are all prime numbers, and I picked these on purpose so that it would have to get large. It kind of forces the equation to just grow exponentially. Because they have no factors other than themselves and 1, really the only way that we can get these numbers to even get close to each other is to multiply them together. So if we take 19 and multiply it by 17 and 13, we'll get some number. And if we take 17 and multiply it by 13 and 19, we'll get that same number. Same thing with the 13. If we take 13 and multiply it by 17 and 19, we'll get the same number. So that's what we're going to tackle here. Let's see. Clear out all of those marks. And we're going to take this top equation and we're going to multiply it by 17 multiplied by 19. And this second equation, we're going to take and multiply that by 13 and 19. And then we'll take this bottom equation and we're going to multiply it by 13 and 17. Now that would mean we have all positive p's, so I'm going to throw in a negative on one of them as well, just by -1. It does not matter which one we pick, because this one's already negative. It'll make the constant on the outside positive. That's why I'm picking that bottom one. But you can pick any. You could even pick this one. I mean, if you wanted to, heck, you could pick the middle one. Doesn't matter. We're going to get to the same solution one way or the other. So the first thing I'm going to do is take 17 and multiply that by 19 to know what I'm supposed to be multiplying by. So 323 multiplied by 323. And I'm going to just cross that out. We don't need that anymore. We know we're multiplying it by 323. So that times 13 is 4,199 p plus, let's take that and multiply it by 41. 13,000 243. That's Q's. And then, let's see, 43. 323 times 43 is negative 13,889 R. And that equals 17 times that same number, 5,491. The negative, though, negative 5,491. Okay, I'm going to write this next one a little bit lower. We actually know what the p's should equal, so we don't really need to crunch that number again. We should get 4,199 p for this second equation here, because for this one, let me actually crunch that. 13 times 19 is 247, so multiplied by 247. Let's see, and that's going to be minus, what's 23 times 247? 5,681. That's Q. That's going to be plus whatever 47 times 247 is, 11,609 R. And that equals, this one's going to be big as well, 447 times 247, 110,409. For this next one, we're going to get negative 4,199p. Remember, it's going to be negative, so 13 times 17 is negative, well, times the negative 1, of course, would be negative 221. So negative 29 times negative 221 gives us positive 6,409. Write that in line with this next one, 6,409. Q. And this next one here, negative 37 times negative 221 is going to give us 8,177 R. That's a positive there as well. And that equals, let's see, 667, negative 667 times negative 221 is 147,407. All right. I'm going to take this same inverse equation and write it down on this bottom one, 4,199p plus, of course, 6,409 Q plus 8,177 R. And that equals, still the same, 147,000, I'm sorry, 407. Now we need to add down. Thankfully, we know what these equal. Those are just going to cancel out. So let's add these Q's together. And again, just use your calculator. No reason not to. We have 13,243 plus 6,409. That gives us 19,652 Q plus, let's see, 8,177 minus 13,889 gives us 5,000. Oh, it's negative. Let me make sure I get that in. Negative 5,712 R, and that equals whatever 147,407 minus 5,491 equals. You're not going to have a question this long on your test, don't worry. 141,916. All right, and for this bottom one, can't know any of the math already. 9,409 minus 5,681 gives us 728 Q plus let's see, 11,609 plus 8,177. That's 19,786R. And that equals, whatever this one equals, 110,409 plus 147,407. That equals 257,816. All right, now we have two new equations. Now getting these to equal each other is going to be a chore. It just is. I'm sorry, but that's just the way it is. Unless we start simplifying these. Everything that I see here, because all of our numbers started off as odd, when we add them together, we're always going to get even. We can at least divide every single number here by 2. We absolutely can. If you also want to think of this in a more abstract way, these two bottom equations right here were both multiplied by 13. That means that everything that exists in this equation is a multiple of 13. Same thing, let me actually kind of uncover this. Everything on the top, these top two equations, right up here, everything up there was multiplied by 19. So we can divide, I believe, all of those numbers up there on the top by 19, and we'll get to a more complete number. So let's do that real fast. If we take 19,652 and divide it by 19, let's see, what am I doing wrong here? Oh, I know what I'm doing. I'm looking at this a little bit backwards. Sorry about that. We can divide them by their what number they were commonly multiplied by, but it's not the 19 in this case. It would be the 17. What we're looking at is this 17 and this 17, because this third equation exists right here. So let's take that and switch it up a little bit. Sorry, I hit the wrong number there. So yeah, this 17 and 17, so we'll take those numbers and divide them by 17. Look at that. We would get 1,000, nope, not in highlighter, there we go. We would get 1,156 Q minus whatever this 5,712 divided by 17 equals, that's 336 R, and that equals 916 divided by 17, 8,348. We can cross this one out. We don't need that one anymore. Same thing with this bottom equation. It's just not 17s in this case, it would be 13s. So let's take everything in this equation and divide it by 13. 728 divided by 13 is 56. Q plus 19,786 divided by 13 gives us 1,522 R. And then 257,816 divided by 13 would give us 19,800. That does not look like an 8. 832. Well, at least our numbers are smaller. We're not quite there yet, but we can definitely get there. We can still divide everything by 2. I'm going to cross this one out. Oh, not like that. Just cross this one out. Let's see. Next step would be to try and eliminate one of these variables. Let's see how close we can get. Let's see. We can divide everything by 2 again and simplify these equations even more, but I don't think that we should. When you have huge numbers like this, one thing you can do is just substitute. I mean, there is a time and a place for substitution even in these 3 variable equations. So I think that's what I'm going to do next. I'm going to take and isolate this q just because it's kind of alone. So we'll do that. We'll take 56Q Q, and that equals negative 1,522R plus 19,832, and then we'll say Q equals negative 1522R over 56 plus 19,832 over 56. And if you have your calculator out, we can crunch these numbers right now and try and get them down as close as we can. Let's see, divided by 56, it's going to be a gross number. So I'm just going to leave it as a fraction for now. If you have your TIs, though, you can hit that and then hit math fraction fraction, or math fraction enter enter, I believe, and it'll put that in its most simple form. That can be really handy on questions like this. But for now, we'll just leave it like that, and we'll sub it in to this equation. All right. So we get 1,156Q, and that's this value right here. We get that negative 1522 over 56 plus, oh, that's R, plus 19,832 over 56, and that's plus, or minus, I'm sorry, 336R, and that equals 8,348. Now we just need to distribute in. Let's see if 1,156 divided by 56 equals anything even remotely pleasant. Divided by 56, nope. There's always a hope. All right. Let's see. You know what? I'm actually going to spare you guys the rest of this problem. This is taking much more space and time than I thought. I'm going to finish out this, and I'll be back to you once I'm done crunching all the numbers. Coming back to you guys, after thinking about this problem, I am actually just going to use the inverse method. These numbers are going to get huge, but I think it's going to be less work than jumping through all this. If the 56 divided by all of those numbers came out to something really, really nice and pleasant, that's one thing, but it's just simply not going to. So what I'm going to do is make the Q's here the inverse of each other. And I'm going to do that by taking this top one and multiplying it by negative 56, and this bottom one by just multiplying it by 1,156. Once I'm done crunching those numbers, I'll be back to you again with the big equation. We'll add them all up, get to an R value, and then plug it in. It'll be much easier from there, I promise. Okay, crunched those numbers. Now we just need to add them together. We know that the Q's will cancel out, thank goodness. And this next one here will take 1,759,432 and subtract 18,816 from that. We'll get 1,740,616 R, and that's going to equal 22,925,792. I'll punch this into my calculator wrong. Let me try that again. 22,925,792 plus 467,488. That equals 23,393,280. Let me put the hatch marks in there. And now for the moment of truth. We're going to take each side and divide it by 1,740,616 and hope that I get what our answer should be. R, we should get 13. So let's see, we'll divide this by 1,740,616. And I did my math wrong somewhere. What I'm getting is R equals 13.439, which I know is not correct. I'm going to call it there. I can jump through this, and I think I would be able to eventually find my error in some of this math. but I'm not going to do that. I'm not going to subject you guys to any more math homework. So we'll take it for this. Even when we're staying super organized with something like this, it can get really complicated really, really quick. I think I was just too ambitious with giving a whole bunch of prime numbers in here. Interestingly enough, all of these numbers, all of these coefficients, and all of these answers are prime. That's why we need to multiply so many times and just get these so huge. I will see you guys in class, and if you have any questions, bring them straight to Miss Kavanaugh or I. We'll see you guys there.